In last lesson we worked on graphing lines, and now what we're going to do is we're going to write equations of lines. So we're going to review the slope-intercept form. Slope-intercept form is simply y equals mx plus b, where m is the slope of the line and b is the y-intercept. And remember, y-intercept is where it crosses the x-axis. So we have y equals mx plus b. That's the form we usually want to work with because that's the easiest to graph with. We also sometimes see this as in function notation as f of x or g of x or something like that. So here's a first example. It's going to be straightforward using the slope-intercept form. It says write the equation of the line with a slope of 2/3 and a y-intercept 0, 7. So this is very straightforward because what we're going to do is we're going to, in this case, just take slope-intercept form and we're going to plug in what we know. We know the slope is 2/3. So we put 2/3 into this for slope, and we know the y-intercept is at 0, 7, so it's 7. And so we have y equals 2/3 x plus 7. Very straightforward. If you know the slope and the y-intercept, you can go ahead and put it right in slope-intercept form. There's other examples where we don't know the slope and y-intercept form, so we are going to use what's called the point-slope form. And you need to know this, so make sure you have this memorized. It's actually derived from the equation of slope. If you remember, slope, this is a good review anyway, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If we were to multiply both sides of this equation by the denominator, we would get point slope form. And so this would cancel, and you're really left with y sub 2 minus y sub 1 equals m x sub 2 minus x sub 1. Now we notice in the equation I just wrote, we still have y sub 2's and x sub 2's and 1's in our point slope form. They're just the 1. So our y and our x, these two are just going to stay as y and x. They're similar to the y and x in slope-intercept form. So what we're going to do is we're going to use point-slope form to start these next examples, but then what we're going to do, we're going to put it in slope-intercept form. So write the equation of a line that has a slope of -4/5 and passes through the point 1, 4. So this 1, 4 is really our x sub 1, y sub 1. And so we have our point-slope form, and we'll plug in what we know. Well, we know the slope is -4/5, and we know this point, we know y sub 1 is 4, so y minus 4, and x minus our x value, which is 1. So there's an equation of the line, but we want to change that into slope-intercept form. So we'll distribute, and we get y minus 4 equals -4/5 x plus 4/5. And then we'll go ahead and add 4 to both sides to finish this off. And we get y equals -4/5 x plus 4 4/5. And that is the equation in slope-intercept form. So if you have a point and the slope, you can plug it into point-slope form first, and then you can use algebra to change it into slope-intercept form. The next one is similar to this one we just did, but it has an extra step. It says write the equation of a line that passes through the points -4, 3, and 2, 6. Well, here we have 2 points, so we're set for a point. So let's write out point-slope form. Y minus y sub 1 equals m times x minus x sub 1. We have a point to put in for y sub 1 and x sub 1. We actually can choose either one. It doesn't matter which one we choose. But we don't have a slope. So what we need to do when we're just given 2 points is we find the slope first. and we just reviewed that. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It doesn't really matter which we choose as our first point and our second point. So what we'll do, let's just do 6 minus 3. So y value minus y value over 2 minus negative 4. And that gives us 3 over 6, which is 1/2. So we just found our slope is 1/2. Now we're back to doing something like the previous example where we now have our slope, and we can plug this into point slope form. So from here, I'll go ahead and use this first point here as our point that we're going to work with. So we have y minus our y value, so 3, equals the slope, which is 1/2, and then x minus negative 4. And we realize that changes to plus. So we'll work with this and put it, this says show your answer in standard form. Standard form, which I didn't explain before, so let's write that in here. Standard form is really just having your variables on one side and the constant on the other. So we want to get the terms with x and y on one side and the constant term on the other. So we're still going to start by distributing. So we have, this is distributed 1/2 x plus 2. And now I want to get the constant to the other side. So I'm going to add 3 to both sides, and I'm also going to subtract 1/2 x from both sides because I know I want that on the left side. And so we're left with, we usually put the x one first, negative 1/2 x plus y equals 5. Now one thing with standard form, if we're going to put something in standard form, we like to not have fractions, if possible, and we'd like the x term to be positive. So this equation has a fraction and x is negative. So what we do is we're going to multiply by the least common denominator, which is 2, but I'm going to multiply by negative 2, so our x term will be positive. So when we multiply this, we get, multiplying here, we get x minus 2 y equals negative 10. And that is in standard form. All right, looking at our next one, we have a graph of a line. Now, having a graph of a line, usually it's going to be easiest to use slope-intercept form, especially if we know where the graph crosses the y-axis, and we do, because that's our y-intercept. So here we can just start with y equals mx plus b, and we want to plug in our slope. Well, for slope, we can really count this off. Here's a few points. Actually, we have 3 of them that hit a lattice point, and so slope is rise over run. And so we'll find slope, which means we'll start at a point, we go down 1, so that's a negative 1, and we go right 3, so our slope is negative 1/3. And so we can write the equation y equals negative 1/3 x, and we see that our y-intercept is a positive 2. So there it is in slope-intercept form. Let's go ahead and change that to standard form. So here's one form of a line, slope-intercept. Changing it to standard form means I want to get the variables on one side, so I can add 1/3 x to both sides. And we'll have 1/3 x plus y equals 2. But what I mentioned earlier is we don't want fractions, so to get rid of fractions, we're going to multiply both sides by 3. So when we distribute that 3, we get x plus 3y equals 6. And so there it is in standard form. So once again, if you have the graph of the line and you can see where it crosses the y-axis, instead of using point slope form, you can just go back to slope intercept form and plug in the information. Next example still deals with graphing lines, but we're going to be comparing we're writing equations of lines, and we're going to be comparing those lines to parallel lines and perpendicular lines. So in this first part it says, how do the slopes of parallel lines compare? So let's draw two parallel lines. And remember, slope measures steepness. So if we look at those parallel lines and think what's true about their steepness, well, their steepness is the same, so their slopes are equal. So if we have two lines that we know are parallel, if we know one of the slopes, we also know the other slope. The next one is a little harder to tell, but if we have perpendicular lines, what's true about their slopes? Well, let's just kind of look at this. Here, this line, it looks like the slope of this line is maybe up 2 over 1. I know it's not on any graph, but so the slope of this line is 2 over 1. The slope of the other line looks like the slope of the other line is down 1 and then right 2, so the slope of this line is negative 1/2. Well, what do you notice about those two slopes? Well, the slopes are negative reciprocals of each other. So, or opposite reciprocals. You can take the reciprocal and then change the sign. Another fact about that is if you multiply those together, you'll get negative 1. But what we need to see with these two, for parallel lines, the slopes are equal. For perpendicular, slopes are opposite or negative reciprocals. So if you know the slope of one line, you know the slope of the perpendicular line is the negative reciprocal. So here we have an example. It says write the equation of a line perpendicular to y equals 3/4 x plus 7 that passes through the point 6,2. Well, we're going to use point slope form again for ones like this, because we don't know the y-intercept right away or directly, so we're going to use point slope form. And so we need to plug in a point and a slope. Well, we have a point right here, so we have y minus the y value, which is 2, equals, I don't have the slope yet, and we'll talk about that in a minute, but let's plug this in, x minus 6. And slope, well, this sentence right here, or this line right here, says it's perpendicular to y equals 3/4 x plus 7. Do not use the 7 in your equation. Okay? Do not. All we need to know about that line is that the slope is 3/4. So the slope of a line perpendicular to this one would be what? Well, we just talked about right here in this question, how do they compare? Well, the slope of the line that's perpendicular to this one is going to be the negative reciprocal. So this slope was positive 3/4. The slope of the line I want is going to be negative 4/3. And so we put negative 4/3 in here for the slope. And now it doesn't say what form to put it in, so I'll go ahead and put it in slope intercept form. We rarely leave it as point slope form. So we'll distribute. So we have y minus 2 equals negative 4/3 x plus 8. And adding 2 to both sides, we get our equation in slope intercept form. Y equals negative 4/3 x plus 10. So this line, the equation of this line here is perpendicular to our original, and it passes through the point 6,2. So a quick summary of some important things you need to know from this lesson. We need to know the equation to find slope. So that slope, now if you have 2 points, you'll go ahead and do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we use this if we have 2 points. If we have the graph, we're just going to use rise over run and we're going to count it off, which these two really mean the same thing. But thinking of it as rise over run is easier when you have a graph. If you have 2 points, you can use this formula to the left. Slope-intercept form. That's y equals mx plus b, where m is your slope, b is your y-intercept. Point slope, y minus y sub 1 equals m times x minus x sub 1. We use that when we don't have a y-intercept and we have a point and a slope, and we plug that in and then usually change it to another form. Slopes of parallel lines are equal. Slopes of perpendicular lines are negative. Actually, I used the word opposite before. Opposite reciprocals. So if the original slope is negative 7/2, then the slope of a perpendicular line would be positive, because we make it the opposite, 2/7.